In this video, I want to take some time to apply the quadratic formula to a few examples and look at a few special cases as well. So let's look at the three examples I have up here. First thing let's do is let's write the quadratic formula on the board so we have it for reference. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Where a is the coefficient of x squared, b is the coefficient of x, and c is the constant. And it's important that when you're setting up your quadratic formula that your constant c is on the left side of the equation symbol and you have a 0 on the right. Otherwise, you're going to get the wrong numbers if you plug in c. So we have all these set up in the right form. So let's go ahead and directly apply the quadratic formula here. So for this first one, we have x equals b is negative 4, so negative 4 plus or minus the square root negative 4 squared minus 4 times 1 times 4 over 2 times 1, which is 2. So we can go ahead and simplify now. Negative 4 is 4 plus or minus the square root of 16 minus 4 times 4 is 16 over 2. So in this case we have our term under the radical symbol here, 16 minus 16, this is equal to 0. And so the plus or minus doesn't matter. All that we're left with is 4 divided by 2, or 2. And so this equation here only has one solution of x equals 2. So now the second example, we have x squared plus 4x minus 12. So our a is 1, our b is 4, and our c is negative 12. And so we have x equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 12 divided by 2. And so now we can go through and simplify this term, and that will give us negative 4 plus or minus the square root of 16 minus 48. I'm sorry, this is a negative 12 here. 16 plus 48 divided by 2. 16 plus 48 is 64. So the square root of 64 is 8. And so this gives us negative 4 plus or minus 8 divided by 2, or negative 4 plus 8 is 12, or is 4, divided by 2 is 2. So if this is a plus, our solution is 2. Negative 4 minus 8 is negative 12, divided by 2 is negative 6. And so here we have two solutions, x equals 2 and x equals negative 6. And so this is the most common solution, or most common type of solution you'll have with quadratic formulas. But now let's look at the third example here, x squared plus 4x plus 12. And so here what we'll have is x equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 12 divided by 2. And now to simplify this, we get negative 4 plus or minus the square root of 16 minus 48 divided by 2. Now you'll notice here, since the second term here is greater than the first and it's a minus, what we're going to end up with here is a negative term underneath the radical. If you write this out, you get to this point and you see that this term is greater than that term and there's a negative sign here. What you can say for certain at that point is that there are no real solutions to this equation. There will be some complex solutions involving square roots of negative numbers, and so I'll go ahead and solve it as though we're taking those into account. But if you're looking for just real numbers, if you get to this point and see this sort of thing here, where you're going to wind up with a negative number under the radical, you can just stop and say that there are no real solutions. But let's proceed to solve it, and what we'll get is 16 minus 48 is negative 32, and so we'll have negative 4 plus or minus the square root of negative 32 divided by 2. Now, 32 is 2 raised to the 5th power, so we can actually pull out 2 to the 4th, or 16, and that gives us negative 4 plus or minus 4 times the square root of negative 2 divided by 2, or negative 2 plus or minus 2 times the square root of 2, negative 2. And so if we're looking for complex solutions, this is a solution to this equation. So this is just 3 different examples of applications of the quadratic formula. These are 3 things you may frequently see. You may see a single real solution, a pair of real solutions, and also the possibility of having no real solutions, just complex solutions.